I'm going to go over a few problems from the Math 3 Unit 2 Worksheet 3, and I'm going to start with number 3. On number 3, we have f of x equals the absolute value of x plus 1, and g of x equals negative 3. And part A asks us to highlight the portion of g of x where f of x is greater than or equal to g of x, and state the interval along the x-axis. So we first need to get a graph before we do that. So the first one, f of x, I will do in blue. And we see it's translated from its parent graph up 1 unit, so the vertex is going to be at 0, 1. Also, there's an invisible one in front of that absolute value of x, which is the slope of the right-hand side. So the slope is 1 over 1, so from the vertex, up 1, right 1, and you can continue that pattern to get the right side of your V shape. And if you reflect that pattern across the vertex, you get your V shape. So that's f of x, and I'll label that f of x. G of x, I'll do in green, is g of x equals negative 3, so the y value is stuck at negative 3 down here. There we have it. So now if we go back to part A, it says highlight g of x, so we're only highlighting g of x, where f of x is greater than or equal to g of x. And this, a way to say this graphically is where is f above g? That greater than sign really graphically means above. Or equal, meaning where are they touching? Well, notice that f is everywhere above g, and so we're going to highlight g everywhere. And so state the interval along the x-axis. Well, if we think about what x values that covers, everything from negative infinity to infinity. Part B now asks us to solve algebraically for x in the inequality notation. So we have f of x is greater than or equal to g of x. Substituting in for f of x, we have the absolute value of x plus 1 is greater than or equal to negative 3. We want to first solve for the absolute value of x by subtracting 1 from both sides. And we get the absolute value of x is greater than or equal to negative 4. Well, we know that when you take the absolute value of a number, it's always positive. So this right here is asking us the question, for what values of x, or when is a positive number greater than or equal to negative 4? Or when is a positive number greater than or equal to a negative number? And the answer is always. It doesn't matter what x values we plug in there, it's always going to be. Even if we plug in 0, the absolute value of 0 is 0, that's going to be bigger than negative 4. And so all x values, or all real numbers, would be our answer. And notice our answer in part A, we said from negative infinity to infinity. Both those mean the same thing. And so that's what we're getting. Next I want to take a look at number 7. Here, if we read the instructions, it says to solve the following absolute value inequalities for x and graph the solution on a number line. Write the solution in interval notation. If there's no solution, explain why. And actually, let me check. I just wanted to see if we were supposed to write the solution here in interval notation, and actually not. It says inequality notation for part B, so we are good. Okay, so 7, f of g of x. There's that notation again that says take g of x and plug it in for x into the function f. And so we end up with the absolute value of 4x plus 1 minus 14 is less than negative 5. First step is to solve for the absolute value of 4x plus 1. So we need to get rid of the negative 14 by adding 14 to both sides of the inequality. And we end up with the absolute value of 4x plus 1 is less than negative 5 plus 14, which is positive 9. Now 4x plus 1 could be positive or negative. The absolute value will make it either. So let's assume the 4x. So we just take whatever that value is, 4x plus 1. And so we want that to be less than 9. Or we could say that the opposite of that value, so negative 4x plus 1, could be less than 9 as well. Both cases would work. In the first case, I'm going to subtract 1, and I get 4x is less than 8. Divide by 4, and we get x is less than 2. Second case, I'm going to multiply both sides by negative 1, and I get 4x plus 1. Remember, you switch your sign when you multiply by negative, is greater than negative 9. Then I'm going to subtract 1, and I get 4x is greater than negative 10. Divide by 4, and you get x is greater than negative 10 divided by 4, which reduces to negative 5 over 2. I'm running out of room here. I'm going to cross out 8. I don't want you to cross out 8, but I'm just going to use this extra space over here to graph this. So here's my number line. Negative 5 over 2 as a decimal would equal negative 2.5. So here's 0, negative 1, negative 2, negative 3. Here's 1 and 2. So our first one, x less than 2, starts at 2 but does not include 2. We want everything less than 2. The reason I don't start at 1 is because what about all those decimal values? 1.2, 1.3, 1.4. I need to include all those. Those are less than 2. But I don't want to include the 2. So everything to the left of 2. And then the other one says x is greater than negative 2.5. So negative 2.5, about right there, between negative 2 and negative 3, greater than goes to the right. And so everything in between negative 2.5 and 2 actually meets both the criteria. And that's what we want in this case, because if we go outside of that, so say we pick the number 3 and try that out, plug that in, it actually doesn't work as a solution. Or if you go below negative 3, if you try negative 4 and plug that in, you'll find out that that's not a solution either. So we want both of these requirements. So to really state that as a compound inequality, we say we want x to be less than 2 and x to be greater than negative 2.5. We need that word and. And means both requirements must be met. Another way to write this notation in inequality notation would be negative 2.5, take the lower number, is less than or not equal, it's less than x, which is less than 2. And if you go back to the instructions, they say to put your solution in interval notation. So interval notation would be parentheses negative 2.5, comma 2. Let's take a look at number 10 now. 10, we want to get the absolute value of 1/7 x plus 2 by itself. So we add 5 to both sides of the inequality and get the absolute value of 1/7 x plus 2 is greater than 8. So that what's inside the absolute value, that 1/7 x plus 2 could be 1/7 x plus 2, or it could have the opposite sign. It could be negative 1/7 x plus 2. Either way, we want that to be greater than 8. In the first case, I'm going to subtract 2 and get 1/7 x is greater than 6, and then multiply. I want to get rid of the fraction, so you multiply both sides by the 7, and you end up with 7 over 7x, which is x, is greater than 7 times 6, which is 42. In the second case, I'm going to multiply both sides by a negative to get 1/7 x plus 2, switch your sign, is less than negative 8. Subtract 2 from both sides, you get 1/7 x is less than negative 10, and multiply both sides by 7 to get x is less than negative 70. So we have negative 70 on the left-hand side. We have 42 on the right-hand side, 0 somewhere in between, and x is greater than 42. X is less than negative 70. So make sure you have the open circle. Make sure you go in the right direction. And notice here we have two intervals, so when we write interval notation, on the left interval we go from negative infinity to negative 70. And then union, second interval, would go from 42 to infinity. And that would be interval notation for this one. If we were to write this in inequality notation, we'd write x is less than negative 70, or x is greater than 42. Notice the word or in this one. If I said and would mean it would have to meet both requirements, which would be impossible. You can't come up with a number less than 70, negative 70, and at the same time greater than 42. So we use the word or to say at least meet one of these requirements here. Next, I want to take a look at 16. 16 says which inequalities are equivalent to what's stated here. And so first thing I'm going to do is divide both sides by negative 2, and I get absolute value of x minus 3 is greater than negative 4. I know those are equivalent expressions, and I also notice that that is what B says, so I know B for sure is what I want. I know A is not what I want because the sign is going in the wrong direction. Everything else is the same. I know that C is not what I want. D is questionable. If you look at what happened, it looks like they distributed the -2 into the absolute value. Are we allowed to do that? We're not allowed to do that? Not sure. Well, let's see what happens. See if we get the same answer if we do that. So for D, I'm going to solve. And we got the -2x plus 6 less than 8 is one option. And the other option is -2x plus 6 less than 8. And solving these, -2x less than 2, x is greater than 1. The second case, multiply by, I'll distribute the negative. I'll get 2x minus 6 is less than 8. And so 2x is, add 6, we get less than 14. So x is less than 7. And I made a mistake on the first one. It should say x is less than 1. Okay, let's compare that with what we would get if we solved the original. The original, if we kept going, we'd get x minus 3 is greater than -4. And the other one would be -x minus 3 is greater than -4. So the first one, we did add 3 to both sides. X is greater than -1. Which is not what we have. In the next one, if I multiply both sides by -1, we get x minus 3 is less than -4. So add 3, and we get x is less than -1. Oh, you know what? I made a mistake on that one. This should be a +4. And so when I add 3, I get +7. So x is less than +7. That matches, but the first one doesn't match. And so they're not equivalent. We throw it out. Let's take a look at 19. It says true or false. The absolute value of 2x minus 4 is less than 12 is equivalent to what's stated here. -12 is less than 2x minus 4, which is less than 12. So this is a compound inequality, and I'm going to split that up into the two inequalities. So one would say 2x minus 4 is less than 12. The other one would say that 2x minus 4 is greater than -12. And if I multiply both sides by negative, I get -2x minus 4 is less than +12. The original, if I were to break that up, I would have 2x minus 4 is less than 12, which is what I have on the top. And I'd have the negative of 2x minus 4 is also less than 12. And that's what I would get as well. So that is true. For 22, we have x is less than 2 or x is greater than 7 is equivalent to this expression. And that is false because of the or. If it said and, then that would be correct. but because it says or, we're going to circle false. Lastly, I want to take a look at number 26. 26 says, a sporting goods store carries softball bats that are from 25 to 35 inches long. They recommend that a softball bat be 5/8 of a person's height. So we want 5/8 of a person's height, multiply 5/8 times h, to be between 25 and 35. So less than or equal to 35, but greater than or equal to 25. So this compound inequality represents that problem in terms of h. It says solve the compound inequality from part A. What we can do, we have three sides here. Got the left side, the middle, and the right side. And we can multiply all three sides by 8. If I do that, I get 200 is less than or equal to 5h, which is less than or equal to 280. And then divide by 5. So divide everything by 5, we get 40 is less than or equal to h, which is less than or equal to 56. When you divide 280 by 5, you should get 56. So that's the solution. Graph the solution on a number line. So say zeros over here, 40, 56. So close circle on these because they're equal at those points. Everything in between. So we're looking at what? H represents a person's height, and we're talking about inches. So if someone's between 40 inches and 56 inches, so part D says, what is the height of the shortest person the sporting goods store carries for a softball bat? And we see that 40 inches is the shortest. And that is all I'm going to do with you guys on this one.